Okay, welcome back Physics 20s to our next lesson, and today we're going to be talking about lesson 1.5, which is kinematic equations part 2. Okay, so how I want to start this lesson off is I want to watch this cliff jumping video, and we're going to try and determine how high the cliff is. This is not my YouTube, it's just recorded from another YouTube channel, and so the link is there if you'd like to go watch it there. It's also going to show the channel at the bottom if you'd like to follow him, as he gets all the credit for making this video. I could not do something like this.
I'm about to send the biggest cliff of my life. That bad boy right over there.
Okay, so that was pretty incredible, and the awesome part for us being able to calculate it is it timed how long it took. So this gives us another variable to figure out how tall the cliff was. So if we're going to solve this using kinematics, we know there's this accelerated motion. When he's falling, he's not going at a constant speed, he's speeding up as he falls. So we need to use a kinematic equation to determine which one I need to list my variables. I need VI, VF, A, T, and D. So the VI, he falls pretty much from 0, so we're going to call that 0 meters per second initially. VF, we don't know how fast he hits the water. The acceleration, now hopefully this is familiar from Science 10, but gravity accelerates things towards the ground at 9.81 meters per second squared. We are going to talk about that more in the next video, but for right now we'll just remember that it's negative because it's going downwards. 9.81 meters per second squared. The time it showed in the video was 3.10 seconds, and the displacement, or how far he is from where he started, is what we're trying to find out. Okay, so in determining which equation, we are looking for displacement. We want everything else except for VF. We don't have that information and we're not trying to solve for it, so that's useless. We don't want the equation to have VF. So when I look at the equation that we have A is equal to VF minus VI over T. That one has VF. And then we look at our next one, which was D is equal to half of VI plus VF multiplied by T. So both of those have VF, but that's okay, we can still solve this. So what we have to do is we have to take that first one, and I'm gonna rearrange it into this, rearrange it for VF, and I'm gonna plug VF into the other one, and then it explodes to give us our new kinematic equation, which is D is equal to VIT plus half AT squared, which is excellent because now we don't have VF in this equation and we should be able to solve. And we are even asking for displacement, so we just got to plug in our values. So I'm going to write D, which is equal to VI, that was 0 meters per second, multiplied by our time of 3.10 seconds, plus half of our acceleration, negative 9.81 meters per second squared, important to include the negative, multiplied by the time, which is 3.10 seconds, and we square the time. Plugging that in, I'm getting a number of negative 47.137. And so rounding to significant digits, we put 0 there because he was stopped, so that's like 0.000. We have 3 digits here and 3 digits here, so this is going to be negative 47.1 meters. The reason why that's negative is because he went downwards, so displacement from where he started to where he finished is in the negative direction. Okay, so let's try another example. This one says, now let's say someone performs a cliff dive that is 20 meters above the water, so we know their height. How long is the diver in the air before they hit the water? Well, we'd have to list our variables, VI, VF, AT, and D. Let's see what they're equal to. VI, same thing, we're going to assume they start from 0 meters per second and then fall. VF, we don't know. Acceleration, negative 9.81 meters per second squared if they're in free fall. The time, we don't know. That's actually what it's asking for in this one, so I'm going to circle it. And the displacement is 20 meters. Now he's 20 meters above, or she's 20 meters above, it doesn't say. And then it's going to be landing 20 meters below. So the displacement is going to be falling, so it's going to be negative 20 meters. And that's good to be consistent there because we have the negative in 9.81. We need the negative in the 20 meters. And so once again, we see we don't want VF in the equation, so we're going to put D is equal to VIT plus half AT squared. And I just need to solve for T. However, you notice that there are 2 T's. Ah, crap, I don't remember that from previous math courses. Don't worry about that. That's okay. We can solve this still without a kinematic equation. And the reason we can do this is because VI is 0. 0 times anything, no matter what the time is going to be, is 0. So this whole thing is going to be equal to 0. And if you add that to half at squared, it's not going to affect it. So I just put a line through this. That is 0, and we don't need to worry about it. So that kind of goes away when our VI is 0. Now we just have D is equal to half AT squared. To rearrange this, I'll put 2D to get rid of the half, divide by A to get rid of acceleration, and square root is equal to our time, and we can solve this. 2 times negative 20 meters divided by negative 9.81 meters per second squared. We square root, and I'm getting an answer of 2.019 seconds. We look at significant digits. We had 3, but we only had 2 there. So that rounds to 2.0 seconds in the air. Okay, let's try another one. This says, how fast is the diver moving when she hits the water? So it was a girl in this case. How fast is she moving when she dives into the water? Well, we can take a look at the same variables here that we have off the start. And now we are asking for VF, and we don't really care about the time because it's just giving us the time. Now you could say, well, I just solved for the time so we can use the 2.019 seconds. And that's totally true. If this was a step-by-step question, you probably just plug that in and you could use a variety of formulas there. But let's say that it didn't ask this question, how long were you in the air? So you don't know that 2 seconds. And it just asked this question, could you solve that in one step? Well, let's take a look at the equations. We're looking for one that does not have time. So we look here, the first one that has time, the second one has time, and the third one has time. So you might see where this is going. We do a rearrangement of this formula, throw it into there, and then all of a sudden, we get our fourth kinematic equation, which is VF squared is equal to VI squared plus 2AD. So we're going to use that for this example. It's VF squared is equal to VI squared plus 2AD. We are solving for VF. It's a nice and easy rearrangement. We just take the square root of that side, scratches that out. VF is equal to VI squared. Well, we said VI was 0, so that gets crossed out. 0 squared is still 0. If you add it to something, it won't matter. So that's just 0. So we just have 2A, which is negative 9.81 meters per second squared, times the displacement, which was negative 20. Really important that we put that negative there, so we get a negative times a negative gives us a positive. And that's what we have to use to take a square root. We can't take the square root of a negative. So really important that you include both those negatives. And when you put in your calculator, I'm getting a velocity of 19.809 meters per second. And when we round with significant digits, I see that again, we had 2 here. That would become 20 meters per second, which is really quite fast to be hitting the water. Want to make sure that you're going feet first in, so you're not going to land on your chest, as that would be a really bad belly flop to have. As we saw in the video, some people are capable of doing cliff jumps from these heights. And just before we finish though, you notice that your calculator gave you a positive answer. Positive means up. So this person jumped off of a 20-meter cliff, and when they hit the water, they're going 20 meters per second upwards. This doesn't really seem to make sense, but no, you didn't do anything wrong in your calculator. You put in the negatives correctly, but whenever you take a square root, you take a square root of a positive value. You can't have a negative. So you're always going to get a positive value. However, you also get a negative value. Again, that seems weird, but whenever you take the square root, the two answers are the positive number and the negative number. For example, if you take 2 times 2, you get the answer of 4. So that means that the square root of 4 is equal to 2. But however, if you take negative 2 times negative 2, you also get 4. So that means the square root of 4 could also be negative 2. So often how you write the answer after taking a square root is you write plus or minus, because both of those solutions will work. So now you just have to determine which one makes sense for the question. Does it make sense that it be going up or going down? And it makes sense that the diver is traveling downwards. That's what the acceleration was, and that's what the displacement was. So we're gonna write this as negative 20 meters per second as our final answer. So that's it for this video. We have now seen all 4 types of kinematic equations. Try the practice questions and make sure you list your variables to determine which of those 4 kinematic equations to use. Ask me any questions you have in the live time, and I will see you in the next video.